All right, so in this section, we're going to go over FastAPI testing, which includes unit testing and integration testing. But to start, what is testing? Well, testing is a way for us to make sure our application is working as intended. Testing is part of the software development lifecycle, SDLC, that aims to identify a few different things. It aims to identify bugs, errors, and defects. It also makes sure that our application meets the user requirements and the specifications that were assigned to us. This overall ensures our software is high quality, reliable, secure, and user-friendly. So let's go back to what is testing. Well, there's really like 3 different ways we can do testing. There's manual testing, there's unit testing, and there's integration testing. So the easiest one to know out of all this is manual testing, and that's because we've been doing it already throughout this course. It's testing ourselves. It's just running the application to make sure that, hey, it looks like it's working like intended and how we developed it. But there's 2 others. There's unit testing and integration testing. So let's start with what is unit testing? Well, unit testing involves testing individual components or units of software in isolation from the rest of the application. It validates that each unit of the software performs as designed. So each unit is a testable part of the application. Developers write unit tests during the development phase. These tests are automated and executed by some type of testing framework. In this course, we're going to be using PyTest. And it has the benefit to identify bugs early in the development process. Now, there's also something called integration testing. So instead of testing a single unit like unit testing, integration testing focuses on testing the interactions between different units or components of the piece of software. The scope for integration testing is a bit broader than unit testing, as we are testing multiple units together. This helps identify problems for the entire solution. So, for example, we call an API endpoint and make sure that the correct solution is returned. In this next section, we're going to be doing a combination of unit testing and integration testing. We're going to start with some unit tests so we can test specific units. But then we're going to switch to integration tests to call an entire API endpoint like /todos and make sure that, hey, that entire endpoint is doing what we want it to do and be able to test the solution that it returns. So how are we going to be doing this? Well, we're going to be doing this by using a framework called PyTest. PyTest is a popular testing framework for Python. By far, probably the most popular. It's known for simplicity, scalability, and ability to handle both unit and integration tests. And there's some reasons to why you should use PyTest. It's simple and flexible, and it has native assertions, which we'll go over in a little bit. It has fixtures, which is known as a feature to set up and tear down objects and other dependencies. And it has parameterized testing, so we can run multiple tests with different data endpoints. So to kind of cover everything that we're going to be doing, we've already been doing manual testing throughout this course. That's just us running the real application to make sure everything's working as intended. But there's also unit testing and integration testing, and we're going to be kind of covering both of these in this section. All right, so let's go ahead and dive into the next video where we dive more into testing in Python. Getting started with testing. So let's go over like kind of the first couple steps. Our first step in our application is create a new directory on our project called test. Inside this test directory, we want to create a new file, which is going to be our init.py file. So __ init___.py. We then want to create another file inside our test directory, which is going to be test_example.py. Now, inside test_example.py is where we're going to write examples for our PyTest assertions. So inside our test_example.py, PyTest will run all tests automatically that sit within files that have the name test in them and have test in the function. So we're going to name our file test_example inside our test directory, because when we run PyTest, it'll find that test directory, and then each file that has test, it'll run that file, and then each function that also has test, it'll then run those functions to be able to test our test files. So for our demo, all tests will be in the test_example.py file, so PyTest can easily find them. As we create more tests for our application, we'll be creating multiple files, but for the demo and example, everything will be in our test example. Now, when we write tests for our application, we will create new tests from a new file that matches the naming convention of the project. So example is our todos.py file will be tested by something called test_todos.py. So it's going to have the same naming convention with test in front. So let's look at how we're going to create our first unit test inside our test_example.py. So we need to write our first assertion that can be tested. And assertion simply means a statement that checks if a condition is true. So if the condition is true, that means the test passes. If the condition is false, that means the test fails. So if we wanted to see a quick example inside our test_example.py, we can create a new function that's def test, so we're going to start with test, equal or not equal, where we can say assert 3 is equal to 3. Then inside our terminal, we can just simply type pytest, because it's going to find our test directory, our test example py file, and then our test equal or not equal function, where it's going to return everything passed. And that's because 3 does in fact equal 3. So to kind of quickly look at a couple different testing functions to see how they operate, we can say def test equal or not equal, assert 3 is equal to 3. That is a pass. But if we went ahead and said def test equal or not equal, assert 3 is equal to 2, well, that fails because 3 is not equal to 2. We can almost do the exact same thing for assert 3 is not equal to 1, which is true, therefore the test passes. And then on the flip side, we can say assert 3 is not equal to 3. Now, that is a fail because 3 is equal to 3. So you got to think of assertions almost as like a conditional, which our PyTest will be using to validate tests. All right, well, I'll see you in the next video where we go ahead and implement this. All right, so in this video, we are going to go over unit testing. And unit testing is how we can test our application code without us actually having to run the application in production or with a QA person who's a manual tester. We're able to write some scripts called unit testing, which will test our functionality of our application to make sure that everything is working as expected. Now, to do this, the very first thing we're going to do is just create a new directory. I'm going to name the new directory test. All right, now inside our test directory, let's go and say new file. And the very first thing we need to do is create our __init___.py file. And then also inside the same directory, let's go ahead and say new file. And we need to name this something that PyTest, which is going to be the framework that we use for unit testing, is able to know that this is a test file. And the easiest way to do that is just start the file with test underscore. So I'm going to name this test_example.py so we can kind of go over the different PyTest functionality. But then I'm going to start naming it test underscore and then the file name that we're testing against. But let's just hang with me and make sure that the very first word in this file is test underscore. So I'm going to call this test_example.py. All right, so now that we're inside our test_example.py, we need to now pip install PyTest. And again, PyTest is going to be the unit testing library / framework for us to be able to test our code. So inside your terminal, go ahead and just say pip install PyTest. All right, it's a quick download. So now we can use PyTest. So the very first thing we're going to do is use assert. Now, assert is spelled ASSERT. And that is how you validate some type of data compared to another piece of data. So inside here, we can say def test equal or not equal, parentheses, semicolon, and then we can say assert 3 is equal to 3. All right, so now if we come inside our to-do, so make sure you are in our to-do directory, which has our test, and I name this test, and that's because that's what PyTest is looking for. So test example. If we come in here now and say PyTest, and we click enter, this will now run all of the tests we have in our application. So right here, we can see that it ran inside the test directory, our test example.py file, and it has one pass. If we go ahead and say assert 3 equals 2, so really what we're saying is does 3 equal 2, which we know is not true, we can then say PyTest and we can see that we get a fail. And we can see that we're getting an assertion error because our assert is returning incorrectly. And we can see that inside our test equal or not equal, we are validating a 3 versus a 2. So what we want to do is say 3 is equal to 3, and that will make the test pass. Now what we can do is also have more than one test in a function. So again, we always need to name everything with test. So the function name you can see is also starting with test. So now we can say assert 3 is not equal to 1. If we run our PyTest, we can see that the one test still passed, but inside that we now have two conditions that must pass to make sure that the test actually passes. So we can see that the first assert 3 is equal to 3 does work, and we're saying assert 3 does not equal 1, which is true. If we change that to a 3 of saying 3 does not equal 3, and then we run PyTest, we can see that we get a fail on the second assertion of our test equal or not equal. So we can change that back to a 1. All right, well, this is like the absolute introduction to unit testing that I wanted to show in this video. And in the next video, we're going to dive even deeper to go over a ton of other assertions that we can use with PyTest. And then we're going to eventually implement PyTest into our full application for FastAPI. So let's hang on and let's continue diving into this journey. And I will see you in the next video. All right, so let's go over some of the PyTest basics. So we've already went over a little bit of assertions, but let's dive in just a little bit more. So PyTest basics, we can validate integers by what we just did. So we can say def test equal or not equal, assert 3 is equal to 3. We are validating integers of does 3 equal 3, which is a pass. We can validate instances as well. So we can say def test is instance, where we can say assert is instance. This is a string of type string, so we're validating that this is a string. And then we are also validating, so we're adding a new assert, that assert not is instance of string 10 is an integer. So we know that the string of 10 is still a string, even though it has numbers inside, so it is not an integer. So we're checking to make sure it is an instance of string is string, and then we're trying to make sure that it's not the same, so string and int. Now we can also validate booleans, so we can say def test boolean, validated equals true, assert validated is true, so we know that the variable validated is true, so it is true. And then we can also say assert hello is equal to world is false. So we know that hello is not equal to world. So what it's going to return is false, so both pass. We can validate types, so we can say def test type, assert type hello is string, And then we can say assert type hello is not an int. So here we are again with two strings where hello is a string, but world is not an int. So they're both passing. We can also validate greater than or less than values. So if we create a new test, we can say assert 7 is greater than 3, which it is. And we can say assert 4 is less than 10, which is also true. We can validate types. So we can say def test list, where we have a number list, which is 1, 2, 3, 4, 5, or any list, which is just happen to be false, false. Assert 1 in num list, which is true. Assert 7 not in num list, which is also true. So we know 7 is not in that num list. And assert all in num list, which is true. And then assert not any list, which is also true. All right, well, I hope this explains some of the PyTest basics, and I will see you in the next video. All right, so in the last video, we went ahead and created this def test of equal or not equal. And in this video, we're just going to keep diving in our unit tests. So the next thing that we can do here is we have def test equal or not equal, and that's how we can validate integers to each other. Now let's go ahead and validate the instance. And we can validate the instance by saying def test is instance. Assert is instance, and we can just pass in a string of this is a string. And we can validate it against the instance of a string. And now also the opposite, we can say assert not is instance, and we can pass in a string of like 10 and then say, is this an integer? And it is not an integer, it is still a string. Now if we go ahead and say PyTest, we can see that all of our tests pass. Extra space to get rid of that yellow line. All right, now also along with is instance, we can do Boolean checks. So let's go ahead and just say def test Boolean. I'm now going to use a variable, so I can say validated equals true. Assert validated is true. So if validated is true. And then we can also say assert hello is equal to world is false. So we know that hello is not equal to world. They're completely different words, so it's going to be false. And we know validated is true because we just created the variable that is true. And if we go ahead and do PyTest, we can see that all of our tests pass again. Now we can also test our type. So if we go down now under our Boolean, we can go ahead and say def test underscore type, where we can say assert type. And we can say hello is string. And then we can also say assert type world is not int. So we're currently at 3 tests. If we do PyTest, we can see that all of our tests are still passing. All right, now let's go ahead and do greater than or less than. So we can come down here and we can go ahead and say def test greater and less than. With an assert of 7 is greater than 3. And an assert of 4 is less than 10. If we do a PyTest, we can see that we did get a failure. Oh, that's because I did the wrong way on that. So 7 is greater than 3 and 4 is less than 10. Let's try this again. We can see that it passed. And now let's go ahead and go over lists. So inside a list, we can say def test list, where we can say num list is 1, 2, 3, 4, 5. And then we can say any list is equal to false and false. And we can say assert 1 in num list assert 7 not in num list, so 1 is in num list and 7 is not in num list, and then assert all num list, or assert not any list. Now if we go ahead and say PyTest, we can see that all of these tests will now pass. All right, well, this is everything we wanted to show in this video, and it's a quick demo of just looking at the equals, the instances, the booleans, the types, greater than or less than, and test lists. Now, in the next video, we're going to go over objects and PyTest fixtures, and I will see you in the next video. All right, so let's quickly go over PyTest objects. So we can create our own Python objects using PyTest. So if we go ahead and say import PyTest, we have our class student. We can say def initialize ourself by passing in a first name, last name, major, and years. And normally we would set this by saying self.firstname equals first name, self.last name equals last name, and then major and years for the exact same thing. And if we have this student and we want to test this student, we'd have to say def test person initialization, where P equals a new student of John Doe Computer Science in 3, where we can say assert P.firstname is equal to John, and then we are also able to pass in a message for future developers. So we can say first name should be John. Assert P.lastname equals Doe, where last name should be Doe. Assert P.major equals computer science. So here we do not have a message because a message is optional. And then assert P.years equals 3. And we're just making sure that each one of these assertions line up with the object we just created. However, if we had to create a new object every single time for every single function, well, that takes a lot of time because we'd have to initialize a new student every single time by hand, by code in each function. Well, PyTest allows us to be able to use reusability on some items by calling something called a fixture. So we can create our Python object the old way, which is, def test person initialization, where we create the object right there called P, and then we test everything. Or we can use something called a fixture, where we can say at pytest.fixture def default employee, which returns a student of John Doe Computer Science and 3. However, for us now to be able to use this student, we are not going to be saying P equals student. Instead, we can pass that default employee as a parameter into our function, which automatically now allows us to be able to use that student as that parameterized value. So right here at the bottom where it says test person initialization, we say P equals student. We would change this all to now say def test person initialization, where we pass in default employee, which now calls the default employee fixture. So now we can call our default employee, which will have all the same values. So now we can say assert default employee.firstname equals John, default employee last name equals Doe, and then major and years. So using PyTest fixtures allows us to be able to reuse Python objects that might be similar within the entire application. Like, for example, we're going to be using PyTest fixtures for our users when we're testing for our application, because we don't want to have to create a user every single time. We're just going to create one user and pass it in as a parameterized value as a fixture. All right, well, that's everything I want to show for this video. Was how to use a fixture, kind of an overview before we dive into the code. And I will see you in the next video. All right, so in this video, we are going to go over PyTest using objects. Now, the very first thing I'm going to say to do is go to the very top and let's go ahead and import PyTest. This will allow us to be able to use everything from PyTest outside of just assertions, but we'll be able to use some of the fixtures that we're going to go over at the end of this video. So now let's scroll all the way back down, and under our list test, let's go ahead and just create a user that we can then test against. So we're going to be testing against objects. So let's go ahead and just say class student, and then I'm going to say def underscore underscore init underscore underscore, where I pass in self first name of type string, last name of type string, major of type string, and years of type int. Then we need to say self.firstname equals first name, self.lastname equals last name, self.major equals major, and self.years equals years. All right, so now that we have an object of student, we can now test against this student object. So let's go ahead and just create a new function that is test person initialization, where then we can say P equals student of John Doe, computer science with 3 years. We can then say assert P.firstname is equal to John, where we can then add a message of first name should be John. Assert.p last name equals Doe, and we can say the same thing with a message of last name should be Doe. Assert p.major equals computer science, and assert p.years equals 3. So again, we are creating a student based on the student above, and we can see that years and years, let's throw an S at the end of that to make it years. So self.years equals years. And let's go ahead and add years right here. So we are testing that the first name is John, the last name is Doe, the major is computer science, and the years is 3. So if we go ahead and just say PyTest right here, we can see that everything passes. However, we can make this significantly better, and that's using something called PyTest fixtures. Now, right here, we can see that we are instantiating a new object in the test, and we have to do this every single time if we want to be able to use the values of that object. So we can assume that there's going to be more tests for that object, and we don't want to have to instantiate a new object every single time we're going to test against it. And that's where PyTest fixtures come into play. And PyTest fixtures will allow us to be able to instantiate an object and then pass it into our test functionality. And this all happens automatically behind scenes, and it allows us to kind of add some dependencies to our test, which will allow us to create less code. So for example, if right above here, we went ahead and said at pytest.fixture, and then we said def default employee, and then we said return our object of our student John, well, now we can use it inside of our test person initialization. And we can do that by calling the function inside our parameter arguments of our test function. So right here, we can just say default employee. Now, I know that this is just a function, but we're going to be saying, hey, when it's inside here, it's going to look for a function named that is a PyTest fixture. And that will allow us to then call this by default, return this object, and now we can use that object inside of our test. So that's a way for us to be able to reuse creating a student or reuse creating any kind of object in our to-do application that we're going to be doing in a little bit. We're going to be creating these fixtures that allow our test to be able to reuse certain components. So now we can just go ahead and delete that initialization of the student P. And now we can use our default employee and change all of these P's to our default employee, which is going to have John Doe Computer Science in 3. So now when we run PyTest, we can see that it's going to pass still because we are using a PyTest fixture, which is going to return an object that we are going to be using in our assertions. Now, the only way to use a PyTest fixture is if you import PyTest. So that's why we imported it in the very beginning. But this essentially is how you can test against the initialization of objects and being able to use fixtures to pass in the dependencies to a test. And in the next video, we're going to start actually writing unit tests for our application, which goes in so much more depth than this. But this is a great starting point just so we're on the same page before we jump in. So I will see you in the next video. All right, friends, now that we have the basics of PyTest figured out, let's go ahead and start writing unit tests for our complete FastAPI application. Now, before we start though, I am going to go inside our main.py file, and I'm going to create a simple route here that just to check if the application is up and running. Now, this is typically called a health check. So if your application is in like production and maybe something's odd is going on, you can always count on hitting your endpoint of healthy or health check. There's a couple different ways you can name it. And all we're expecting to do is see, does the connection work and do we return a status code of 200? So right here, I'm going to say app.get/healthy, where we are going to call a function of def health check, where we just return a status of healthy. All right, so there we have it. We have our new functionality that just returns healthy. And I'm going to make a space just to get rid of that yellow line. Now, if we ran our application, this would return just a dictionary that says status and healthy. So the very first thing we are going to test is this endpoint. And we're making this endpoint because we don't have to create mocks of objects or deal with any kind of dependencies. We're just going to do a simple check against an API endpoint for FastAPI before we dive deeper. So to do this, let's go into our test directory. And inside here, let's create a new file. And we're going to name this test_main.py. All right, so we are checking this endpoint right here of /healthy, our health check, and seeing if it returns the correct information. So to start, we are going to need some dependencies that we may have not had to use before. So the very first thing we're going to do is test client. And we can get that from FastAPI. So we can say from FastAPI.testClient import test client. So if we hover over test client, right here, we can see what it is. It actually comes from Starlight. And it is just a simple way for us to be able to create a client for our app. So right here, how we create this app equals FastAPI. We're essentially doing the same thing. We're just creating a test one of those. Now, to be able to use test client, we need to grab the app from our application. So we can say import main, and that'll import our main file. And then lastly, we want to say from FastAPI import status. We then want to connect our client to our test client with our app inside. So we can say client is equal to test client and pass in app. And we know that we need to get it from our main, so we can say main.app. And then here we can run our functionality. So we can say def test return health check. Response equals client.getHealthy. So we're calling our /healthy endpoint from our client.get. And then we want to say assert response.statuscode equals status.http 200 OK, and assert response.json is equal to a dictionary with status and healthy. All right, so let's go ahead and run this application by doing a PyTest. So we can see that we are getting one error. If we scroll up, we can get through these warnings, but we are seeing that we are going to get an HTTPX error. Now, an HTTPX error is a way for us to be able to pretty much dynamically call URLs and API endpoints automatically through a library. So to be able to fix this error, we just need to say pip install HTTPX. All right, now that we did that, let's go ahead and say PyTest again. And we can see that we are getting one more error. I wonder what this is. Well, we can see that we are getting an error of no module named main. This is weird because we know that we have a module named main. Well, the reason this is happening is because we have not directed our application to a parent root folder. We can be calling this application directly from our main.py file, and then our main.py file is able to find what file we're talking about from using relative paths. But how Python works is it wants to find a root package and then use these underscore initialization files to be able to find the child pages or the child files underneath the root package that's specified. Now, in the next video, I'm going to show you how we can kind of change our project to be able to find this root project. So then we can call our FastAPI application from that root project. And then it's also going to work with PyTest. So PyTest is not able just to find the file and do the relative paths automatically. We need to make sure that our application is in a correct format that PyTest and our application can work. So let's go over that in the next video. All right, so the last video ended with us getting this no module named main error. And that's because we haven't specified a root project for our Python application. So right now we're sitting in our to-do file, but what we really want to do is say our FastAPI file, which has our application inside. So what I'm going to do here is to just start off, I'm going to say file, open, and I'm going to say FastAPI is going to be the file that I'm opening. So it's in my desktop, FastAPI to-do app. Here's FastAPI, and we know that our to-do app is inside. And I'm going to say this window. All right, so here we are. We are currently inside our FastAPI application. So now what we have to do is go through here and fix our dependencies to make sure our application works correctly. Now, what we're going to be doing here is now that we're in our FastAPI directory, which is the parent directory of our to-do app, we can now go ahead and say unicorn to-do app dot main :app -- reload. However, when we do that command, we can see that we are now getting an error here. And this error is because, again, we are using the same package that our PyTest is looking for, which is our entire FastAPI package, but we haven't done relative imports yet for this application. So we can't find the module of models. So if we jump inside our main.py file, here we can see that it cannot find models. So what we want to do here is we can say from .models import, and instead of importing all of the models, I'm going to say import base. And now we can remove this models in front. So here it's now from .models import our base. Now we're going to need to do the exact same thing for this database. So we can say from .database. And what that's going to do now is the relative import. So we are saying inside this directory, our main and our database are in the exact same file, which is the to-do app. So our models, main, and database are all next to each other. Well, now we also want to say from routers, import all of this stuff. And we know that routers is technically in the same directory too. It's in this to-do app. So we can just say .routers. Now we need to do essentially the exact same thing for all of our files thus far. So let's now close out of this and let's now go into our models where we need to say from .database. We then need to go inside our routers so we can go open up our admin and objects that we imported like Pydantic and FastAPI. We don't need to do this for, we only need to do this for our own files. Now, like our last files, like inside our models, we were using .database because they're in the same directory. For models, we're going to need to go up 2 directories, right? Because in our admin, we have to get out of routers and then go and find our models file. And we can do this by saying 1 dot, 2 dot. 2 dots mean 2 files out. So we need to go 2 files out of our models. We need to do the same thing with our database. 2 dots out of our database. And for our auth, we only need to use 1 dot because it's in the exact same file of our admin. All right, now let's go into our auth file and we can do the exact same thing here. So for database, we need 2 dots. For our models, we need 2 dots. And that's all we need there. Let's now go into our to-dos where we can say models needs 2 dots and database needs 2 dots. And lastly, let's go into our users where we can see models takes 2 dots. Database takes 2 dots, auth only takes 1 dot. All right, I'm just going to say file, save all just in case I missed a file. And now I'm going to say unicorn to-do app .main :app -- reload inside our FastAPI directory, which is 1 directory higher than our to-do app. And I'm going to click enter. And we can see that we are having an error still. So inside our main file, we are getting an issue with our routers, and inside our routers.todo.py, we are having something funky going on. So let's go ahead and just delete that. Must have accidentally added that character at the end, but that's why that error showed up, was because of that character. So now we can see that our application is working correctly in here. I'll just do it again just to kind of prove it because of that last weird error. And now our application is working correctly. We are now essentially saying, hey, we want to start at the FastAPI package and then use relative imports to find all of the files that we need to find. Well, now if we go inside our test and we go inside our test main, we know that our main file that we're trying to use here is a little bit out of the scale. So it's inside our test and we need to get it out of test and into our main. Well, we can do exactly what we were doing before. We can say from .main import our app. And then once we do that, we can remove this main dot because we already have the app and everything is looking good. So now we know that our application works correctly. And when I say PyTest, because we changed the directory to now work with PyTest and we click enter, we can see that we are going to get everything passing and working correctly. All right, and now the last thing we want to do is we're seeing these warnings. Now, these warnings come from PyTest, but it's not even doing warnings against our application. It's doing warnings against the dependencies of our applications. We can see like crypt is deprecated and planned for removal in the next Python. So right now we can just kind of ignore everything because these are libraries. When the new library comes out, it'll probably fix it on its own. It's not something that we have to do. So just to make it a little bit cleaner for our application, we can say PyTest -- disable -warnings. And now when we run our application, we can see that the warnings are hidden and it only shows our tests. Now, if you want to keep the warnings, that's perfectly fine. It's just kind of irrelevant in our case because it's going to be libraries. If you're trying to upgrade the libraries and do all that stuff by yourself, then you're going to want to see the warnings. But since we're relying on the owner of those libraries to keep their application up to date, feel free just to do disable warnings for now. This was kind of a big video. We kind of rechanged our entire application to be able to work differently. Now, one thing I do want to note real quick is if we did CD into our to-do app and we wanted to do our normal unicorn main:app -- reload, this will not work anymore. It's because it's attempting relative imports with no known parent package. So now that we have added relative imports and a parent package, we need to do it from outside. And instead of saying main:app, we want to use to-do app.main. So inside our FastAPI, we want to go into our to-do app and then do everything the exact same of main:app -- reload. And that's how we're going to be starting our application from now on. All right, so now there's only one more thing we have to do. And since we changed our relative path for our application, we're now calling it from our FastAPI project, we can see that we created a new database using SQLite. And this is only if you are using SQLite as your database because it's now saving it in a different location. If you have a path to a professional database like Postgres or MySQL, you do not have to do this. But outside our main directory, which is our FastAPI directory, we can see that it has a to-dos app.db. And inside our to-do app, we have a to-dos app.db. If you want to keep the same database, we are going to need to delete the outside to-dos app.db because that's the one that we just created. And then you're going to want to grab this to-dos app.db and just slide it into our FastAPI directory and then say refactor. So what we did was just move the to-dos app.db outside of our to-dos app and placed it inside our FastAPI folder. So now if we go ahead and run this application, the application will run perfectly fine. And we do not have to create a new database or anything because we're just going to be using the database that is our original database. We just moved it to the parent directory. All right, we covered a ton in this video. And I'll see you in the next where we just keep diving into creating unit tests for our application. All right, so in this video, we are going to go over how to set up test dependencies and a test database for our application. So we'll start with a test database. Like, what is a test database? Well, we need to create a fake database that can store data that we're only going to be using for our tests, not for production. So we're going to have two databases, a production one and a test one. We then need to create testing dependencies that are separate from our production dependencies. This way, we can do integration testing to make sure our entire project is working correctly when we run our tests. So when our app is live, we're going to be using our production dependencies in our production database. But when we run our tests, we're going to be using our testing dependencies in our testing database. And we're going to have all of this in a separate shared dependencies in a different file later on. So we're going to have our shared dependencies separated within our application. So how are we going to create these dependencies for our test? Well, we need to create a new file called our test_todos.py, which is going to be testing our todos.py file. We then want to create a new database engine for our testing environment. So we can do this by saying from SQLAlchemy, import our create engine. And then we want to say SQLAlchemy _database _URL equals a SQLite database that we're going to call testdb.db. Now, I really want to make this clear. This is not going on top of what we already did with our database.py file. That is our production stuff. This is only for testing, so don't change anything that we've already done. We're just going to be adding a new database. So to see this in action, we need to add the new engine. So once we write this code, we then want to say from SQLAlchemy.pool import static pool. And then we want to create our testing engine. And we can do this pretty much exactly how we do our production database, but we're going to be calling our testdb. All right, so after we do this, we now want to create our testing session local and our testing base. So we need to import from our database, our base, and then we want to create a new testing session local. So we can say testing session local equals a new session maker. where our auto commit is equal to false, our auto flush equals false, and our bind equals engine. This will look very familiar to what we have in our database.py file. However, it's not the same. We are using testing stuff inside here. So I want to make that like super clear because I don't want you to get rid of your production database. We are using a test database here. So when we run our tests, we're going to use our base.metadata.createAll equals bind engine because that will create our test database. So how are we going to set up our dependencies then? Well, we need to set up our get testing DB dependency. To do this, we're going to override our normal get DB. So our normal get DB that's inside all of our files, we want to say def override get DB, which DB equals our testing session local. We then want to try yield or DB, and then finally db.close. And we can override these dependencies by inside our test, we can say app.dependencies overrides, where we pass in our get DB, which is going to equal our override get DB. And that is the name of the function we just created. We then want to go ahead and mock our current logged in user for testing. And we can do this by simply saying def override get current user, which returns our username of coding with Roby, ID of 1, and user role is admin. And then just like our other dependency injection, for our test, we are going to override our normal get current user with our override get current user, which is again the name of the function we just created. Now, I know this can be like, what the heck is going on? We're going to go over this step by step in code just so you know exactly how to do this so you have a separate testing environment. So just overall, our normal way of doing everything, we have an app that is equal to FastAPI. We're still going to keep that alive. However, to make sure FastAPI knows this is a testing environment, we need to wrap it in a testing client. So inside our test, it's going to say client equals our test client, and we're going to pass in our app. So when these files are ran with PyTest, FastAPI knows that, whoa, okay, these are tests. We don't want this to actually go to production. All right, now, if you're confused, that's totally fine. I wanted to kind of give an overview of what is about to happen. And I'll see you in the next video where we just continue diving into creating tests within our FastAPI application. And I'll see you there. All right, so two things have been accomplished. We have inside our test directory, we have done our test example, which is kind of all the example assertions from PyTest. And then we have our test main, which is just checking to make sure that our application is healthy. And then we changed all of our applications to have a root path. So if we go ahead and say PyTest with our warning of disable warnings and we click enter, we can see that all of our tests pass. So what we need to do now is actually test our application. And it's going to be a little bit harder to test our application because we have to handle our dependencies through tests. So if we go ahead, for example, and we just look at our todos.py, we can see that the very first thing we can try and test against is this read all functionality. And what we need to do to be able to test this read all is we need to be able to mock a user, mock a database, because we do not want to test against our production database. We want a test database. And then we need to mock a response or at least save a to-do in our test database. So let's first go ahead inside our test directory and say new file. And here I'm going to call this test_todos.py. And here we need to go ahead and first create our fake database. So the very first thing that we're going to have to do is go ahead and say SQLAlchemy _database _URL equals SQLite ///testdb.db. All right, so now that we have our path, let's kind of talk about what this path is doing. So this path is actually going to create a new database when this is ran on our root directory, which is going to be right here next to our todos app.db. But our to-dos app DB is going to be our production database. So this, for example, is going to be our production database. If you have MySQL or Postgres or whatever, that's going to stay your production database, and that's defined in your database.py file. But you can still use SQLite as a testing database. So it's going to be right here in our application, and we're going to add it to do, delete to-dos, and do all this stuff to make sure that our application actually works. So your application is going to actually have two databases, one for testing and one for production. So this is going to create a new DB right here. And the next thing we need to do is kind of follow the same philosophy that we did with creating our normal database. We need to import our engine. So up here, we can say from SQLAlchemy, import create engine. And then underneath our SQLAlchemy database.url, we want to say engine equals create engine, where we're going to pass in our SQLAlchemy database URL. So it's going to be our testing URL. Connect arguments is going to be equal to check same thread of false. With our pool class equal to static pool. And we need to import static pool from SQLAlchemy.pool. Import static pool. Now, the next thing that we need to add is a testing session local. And that's going to be our session maker from our database.py file that comes from our SQLAlchemy.orm. And this is a way for us just to be able to create a separate testing environment completely that's isolated from our production database. So let's go ahead and just say testing session local equals our session maker, where we can say auto commit equals false, auto flush equals false, and bind equals engine. Cool, and now the next thing that we need to do is add our base from our actual database.py file. Underneath our recent import, we can say from ... database. So we need to find our database from our relative path of where we are, import base. And now here we can say base.metadata.createAll bind equals engine. And now what we need to do another thing, and this is kind of like what we do with our databases. So if we look at our to-dos.py file, we can see this getDB, where we call this session local. Well, we know that we use dependency injection to be able to fetch this DB on each call. So if we scroll down here, we can see that we're going to be calling our DB dependency, which then is associated with this annotated session of our dependency injection of getDB. What we need to do is override this functionality only when we call this through a test to call our test DB instead of our production database. So what we can do here is inside our test underscore to-dos.py, we can go ahead and say def override getDB, where our DB is equal to our testing session local, and then everything else will be the same there, where we can say try yield DB. Finally, db.close. And now to be able to actually use this override getDB, we need to use a app dependency override. So kind of like how we are using dependencies right here, we need to say, hey, when we're running a test and we use this dependency injection, we need to override the getDB call, which is right here. We need to override this getDB call to instead call our override getDB. And that's because our DB is pointing to our session that's testing and not our production database. And to be able to do this, we can say app.dependency overrides where we're going to say when our getDB is called, we want this to equal our override getDB. All right, and we need to import our app. So up here, let's go ahead and say from .main import app. All right, so now that we have our dependency overriding our getDB, we'll wrap up the video here, and I'll see you in the next video where we continue adding all the dependencies we need for our test to-dos before we can actually test against it. And I will see you in the next video. All right, so we ended the last video by creating our override getDB and then adding our app dependency override of our getDB equals our override getDB. But now we know that also inside our todos.py file, we have this user dependency. And we can see that our API endpoint of read all will call our DB dependency to find our production database and our user dependency to find the authenticated user. Now, what we already set up is when this application runs, we're going to check our test database, which is not yet created. But what we also need to do is override that user. So this user that we're checking to make sure is authenticated, we need to make sure that we just mock and fake that user whenever that dependency is called. So right here under our def override getDB, let's go ahead and say def override get current user. Because if we look at our to-dos, we can see our user dependency is in fact calling our get current user. And we need to mock that. So right under this, let's go ahead and just say def override get current user. Where we just return a dictionary of username, colon, coding with Roby test, ID of 1, and user role of admin. All right, and the same thing that we did down here, we can just go ahead and copy this and paste it right under. But what we want to do here is override get current user with our override get current user. So we're overriding two dependencies that we need for our call, which is the database to redirect our production database to our test database when we're running tests, and our user. So we're not actually validating a JWT or authentication. We're just going to be returning this fake user. So then we know we can test against the ID of 1 or username of coding with Roby test inside our tests only. Remember, there is a different database between our tests and our production, so these users will not be able to be used when actually running the application. All right, and now what we need to do is be able to actually call these specifically. So we can scroll back up and we can say from ... routers to do import getDB and get our current user. So now they're properly going to be getting overrode when we run the application. All right, and now the very last thing we need to do is make sure that we are forcing our application to be ran as a test. So what we can do here is we can say from FastAPI.testClient import test client. So now that we imported test client, let's scroll back down, and right under our dependencies, we can go ahead and say client equals test client, where we pass in our app from our FastAPI main. So what we're saying here is we are changing our dependencies on our test. We are then wrapping it within our test client, so the application will know it's a test. And then we're setting that to our client, which is what we are running here within our test file. So now let's just go ahead and write our test. So we don't have anything in our test DB. So what we can just do here is say def test read all authenticated. response equals our client.get slash. And then let's just check to make sure our status code is equal to 200. So we can say assert response.status code equals status.http 200 OK. And we need to import status from FastAPI. So if we scroll back to the top, we can just say from FastAPI import status. All right, so right here, let's go ahead and try to run our test. So we can see that there is an error, and that's because our session maker is not defined. I must have spelled session maker incorrectly. So right here, let's go ahead and change that to session maker with an N. And I also forgot to add it up here. So let's go ahead and just say from SQLAlchemy.orm import session maker. All right, now let's go ahead and try it again. And boom, we can see that our test 100% passed. And we are actually validating that, hey, when we call this, we are getting a status 200. And for example, let's open up our projects. And now we can see that we have a testdb.db literally sitting in our application. So what we can do now is just validate that our response is just going to be an empty list because we literally don't have anything inside right now. So we can go ahead and just say assert response.json equal to an empty list. And now let's go ahead and run the application again. And we can see that it still passes because we don't have anything inside here just yet. And in the next video, we're going to add a fixture which will say, hey, every time this application runs, we're going to add a to-do to the database to test against. And then at the end of every function, we're going to delete everything from the database. So let's go ahead and do that in the next video. All right, so far we are testing against our testDB, which is correct, but our testDB is just returning nothing inside our test read all authenticated to-dos. And that makes sense because there's literally nothing in our test database. But what we want to do is when this test is ran, we add an item to our database. We can then read to make sure that, hey, this API endpoint is working as we expect. And then we want the test to automatically delete the to-dos inside the database on runtime. So when a test is ran for every single function, we want to add a to-do, run whatever operation we need to run on it, and then delete everything from the database before the next test gets ran because we want to make sure that it's a clean database for every single function because we want every testable function to be completely isolated from one another. All right, so what we can do here is create a fixture. And if we remember from our test examples, a fixture is something that we can create that happens before the function is called. So to be able to do this, we need to import two things. We need to import PyTest, so we can just say import PyTest. And then we want to import our to-dos from our models. So we can say from ... models import to-dos. All right, so we're going to have our to-dos so we can mock a to-do and save it to the database before we run it. And then we have our PyTest so we can properly configure a fixture for our application. All right, so let's go back down. And I'm going to add this right under our client equals test client. And what we can do here is we can say at pytest.fixture. So it's going to be an annotation. And then we can say def test to do. So we're going to be calling this function to create a fake to do, where our to do is equal to to-dos from our model, where title is equal to learn to code. Description is equal to need to learn every day. with a priority of 5, complete equals false, and owner ID is equal to 1. So just remember, we're making the owner ID equal to 1 so it matches up with our fake user that we're returning on our dependency, which we are setting to an ID of 1 because we're checking against that user's ID to all the to-dos with the owner ID is equal to that. We then want to say db equals our testing session local. We then want to say db.add our to-do and then db.commit. So right now we are committing this to-do to our test DB. We then want to say yield DB, which will make it run until the end of our function. And then we want to say with engine.connect as connection, connection.execute. So we're writing a SQL query here. So we can pass in text and then delete from to-dos. This will delete everything from our to-dos table that is inside our testing database. And then connection.commit. All right, and then we can go ahead and call this fixture by passing in this function of test to do as an argument inside our test read all authenticated. Now, really make sure that you're setting this database up with your testing session local. If you accidentally add the production database here, it will run all of this stuff against your production database and delete everything. So make sure that you are in fact using our testing session local here. All right, let's open up our terminal and let's run PyTest. And we should see a failure, which we do, but not 100% the right error. So let's scroll to the top. And right here from our SQLAlchemy, we can see that we forgot text. So SQLAlchemy create engine, comma, text. And now let's run it again. All right, so this is now the right error we're supposed to be seeing. So we're testing right now against an empty list. So we can see right here, assertion response.json equals an empty list. And right here, we're saying, hey, your empty list does not equal what we actually have inside. And what they actually have inside is, in fact, this information for a new to-do. So what we want to do is just recreate that as a JSON. So what we know is they're, in fact, going to be getting a list. And then inside the list, there is going to be an object. And that object is going to equal that to-do that we just created inside our fixture because we're saving it to our test database. We're fetching and getting it. And then after this is ran, we delete it. All right, so that needs to be really clear that we delete the to-dos after our test is already complete. And that happens because of our yield. So now inside here, let's just go ahead and say complete is false. Title is learn to code. Description is need to learn every day. ID is 1. Priority is 5. And owner ID is 1. And the reason we are having each of these as a string, that's because of JSON format, which is key value pairs. So now that we added this, and this will match all the information here. So learn to code and need to learn every day, ID of 1. Now if we run PyTest, we can see that our test successfully passes. And that's because we are fetching the one to do from our database. And we can technically run this as many times as we want because we know it's always going to be passing because it's deleting all the to-dos at the end of the test. So each time we add a new to-do, it's going to delete that to-do. So it's not like we're going to be adding multiple to-dos in our database. And now this list is going to be incrementing each time because there's going to be a multitude of to-dos inside the database. We're deleting them each time. So we know there's always going to be only one to-do in our database each time this is ran. All right, well, in this video, we created our first test read all authenticated with a fixture and our dependencies mocked. And I will see you in the next video. All right, now that we have wrote our test for our test read all authenticated, now let's go ahead and test against all of the other functionality we have in our todos.py. Because we already have our dependency set up, this will now be easy for us to do. So if we look at our to-dos, we can see that down here, we are doing this one right now, which is read all. And now we want to read all based on a single to-do. And we are going to be doing almost the exact same thing here, because we're only going to be checking for a single to-do. So if we go ahead and just copy and paste this exact test, we can see that instead of saying test read all, we can say test read one. Make sure these are different names. We want to pass in our fixture of test to do because we want to make sure there is one in our database. We can say our client to do. So inside here, we can see it's /to-do/to-do ID. So we want to say to-do/1. We want to make sure that our cert response is a status of 200. And our response is actually going to be the exact same as this one, but instead of a list, it's just going to be a single object. So now if we go ahead and run our test, we can see that all 10 have passed because we're successfully reading that one to do based on the path parameter of 1. But we also want to test, what if we type in a to-do that does not exist? Well, we want to be able to test against that as well. So what we can do here is just say def test read one authenticated not found. So we are saying that to-do is not found, but the authentication does work because we're returning our mock. So we can say response equals client.get /to-do/999. And a search response that status code should be equal to a 404 now instead of a 200. And our assert response.json should equal detail of to-do not found. All right, so now if we run our PyTest, we can see that 11 tests pass. So this does pass and is successful. And for example, if we went and said this was going to be a 200 and we ran it, this will fail because we are expecting a 404. So boom, there we got it. We now have all of these tests passing, and I changed this back to a 404, so this technically will pass if we rerun it again. And what we want to do now is go ahead and test for creating a to-do. Now, to test for a creation of a to-do, we need to do a little bit more work. And why is because we need to create a request, which is going to be a new to-do. And we will do that in the next video. All right, so in this video, we are going to test against creating a new to-do, and that's by calling our post/to-do. So the very first thing that we need to do here is just say def test underscore create underscore to-do. And we will pass in our test to-do, which is our PyTest fixture, which automatically adds a test. And then we want the new request to be request data equals, and then here we're going to create a JSON of title of new to do, description of new to do description, with a priority of 5, and complete equals false. That's going to match with our Pydantic to-do request. All right, then we want to say response equals our client.post, where we go and call slash to do. And we want to also pass into our client a new JSON, which is equal to our request data. And if we just do this, we should get a assert message of response.statuscode is equal to 201. So now let's go ahead and open up our terminal and say PyTest. And now we can see that, hey, we have 12 tests pass. Now, what we can do is test this even more and make sure that our to-do is actually in there, because inside our to-dos.py file, we can see our .post just commits, and that's it. We don't really return anything other than a 201 that we tested against. But if we want to check even more to make sure that this is inside here, we can then go ahead and say db equals our testing session local to create a connection to our test DB. We can then check for the model. So we can say model equals db.query, todos.filter, todos.id is equal to 2.first. And remember, we're checking for the ID that's equal to 2 because our fixture test is going to add the ID of 1. So after that's already submitted, then our function gets called, and then here we are submitting the second to do before our fixture then deletes everything. We can then go ahead and say assert model.title, so what we just got from the database, is equal to our request data.getTitle. Our assert model.description is equal to our request data.getDescription. Our assert model.priority is equal to our request data.getPriority. And our assert model.complete is equal to our request data.getComplete. So now if we go ahead and do our PyTest again, we can see that the same amount of tests pass because the function itself is considered the test. But we are now saying, hey, after we save the to-do, let's go and fetch the to-do to make sure all the information is there. And it is there. It's all matching up perfectly. So that is how we test our create to-do using mocks and being able to submit a request data to our endpoint. And I will see you in the next video. All right, so in this video, we are going to add tests for updating and deleting to-dos. So the very first thing we can do here is create a test for updating our to-do. So we can say def test underscore update underscore to-do, where we pass in our test to-do fixture. And what we want to do now is pass in a request of title, description, priority, and complete, and to override whatever we have at the ID of 1, which is going to be the fixture, and to validate that we are in fact updating. So what we can say here is request data is equal to brackets, where title is change the title of the to-do already saved. Description is need to learn every day, which is going to match the fixture. Priority of 5 and complete is false. We can then say response equals client.put, where we're going to be calling our slash to do slash 1. With a JSON that is equal to our request data from our test. Our assert is going to be response.statuscode, which is equal to a 204, which is our put update status code. And then we want to say db equals our testing session local. where we can now validate that, hey, inside our test database, we are in fact validating the change correctly. So then we can say model equals db.query todos.filter todos.id is equal to 1.first because we're checking the fixture that is going to take the ID of 1. And then assert model.title equals change the title of the to-do already saved. All right, so now if we go ahead and run our PyTest, we can see that it passes and we are successfully updating our to-do. Now, we want to do the exact same thing for when we test to make sure that the to-do is found. So what we can do here is pretty much grab everything right here and up. Where it's going to be the test update to do, but we're going to say not found. Where we're going to be passing in the same exact information, but instead we're going to try and override our to do /999, where we're going to pass in our JSON request. If we go ahead and run the test right now, it should fail, which it does because we're receiving a 404 and not a 204 because this to do does not exist. So let's go ahead and change this to a response.status code of a 404. And we want to make sure that the .json is equal to detail to do not found. And let's go ahead and run the test. And we can see everything passes. So even though we have a fixture inside, if the to-do ID is not found, we return a 404 with to-do not found. Perfect. All right, now for the last two tests, that's going to be around our deleting of to-dos. So we can say def test delete to-do, where we're going to pass in our test to-do fixture, which is going to add a test to-do, and then we're going to delete that specific to-do. And then we could say response equals client.delete /to-do/1. Where the assert response.status code should be equal to a 204. DB equals testing session local. Model equals db.query to-dos. By the filter, where our todos.id is equal to 1.first. And really, the model should come back as none because it should not exist. All right, so now if we go ahead and run our tests, we can see that everything passes. And that's because we added a to-do here, we delete the to-do, we get a 204 from the call, and then we're validating that inside our test database that there is no to-do at the first ID. And now let's go ahead and kind of do the exact same thing. So we can copy this over. But here we want to say test to-do _ not found. Let's just remove the fixture, change this to 999, where we should be getting a 404 now for this API endpoint. And then we should also be getting an assert response.json of detailed to do not found. And if we go ahead and run this test, we can see that they all pass. We literally just implemented all the tests for our todos.py file with mocking all of the dependencies, adding a PyTest fixture to be able to add to-dos automatically into our application. And we technically have inside our project file two databases, one for our testing and one for production. All right, well, this is awesome stuff. And I will wrap up this video here, and I will see you in the next. All right, so in this video, we are going to create a utils file, which will cause and create some reusability within our testing platform. So as we know, when we created this test to-dos, we have a lot of code that just set it up with all these dependencies overriding, being able to create these fixtures, these database connections, and we don't want to have to do this every single time. That'll be a ton of work and a ton of code that we can just be reused within each of our tests moving forward, because we have our to-dos, but we still need to make our admin tests, our authentication tests, user tests. We have a lot more tests that we still have to create, and we don't want to have to rewrite what we can reuse each time. So let's go into our projects and go inside our to-do app and inside our test. And let's go ahead and create a new file called utils.py. Now our utils is what's going to have all of our reusable code. So what's considered reusable? Well, this SQLAlchemy database, our engine, our test session local, our base metadata create, and our override DB and override user is all considered reusable. So let's go ahead and just grab all of this. So the very first thing we have is our app dependencies. Now let's go inside our utils and just paste it inside. Now, something else that's reusable is our client of our test client app and our test to do fixture. So if we scroll down here, we can grab this entire fixture and our client equals test client app, grab that, and also paste that inside our utils. So our utils is now going to have our SQLAlchemy database URL connecting to our database session, our override get DB, our override get user, our test client, and our fixtures. All right, so the only thing we should now have in our actual test to-dos is our app dependencies that we're overriding. And that's because we are actually overriding them within our to-dos. And that's a big thing that a lot of people will miss is when we're overriding our get DB and our get current user, it needs to be from the relative path of what we're testing against. And I'll kind of walk through that later on in the video. But right now, we want to keep our app dependencies here and then all of our tests. So what do we not need? Well, all of these, all the way down to here, we can grab and put into our utils. So our create engine, our text, our static pool, our session maker, our base, and our app. So let's go ahead and grab all of those and import those here in our utils. All right. We then also want to grab our test client and move that into our utils.py. So all we should have in our test to-dos.py is our get user and get DB, which we're using for our app dependency overrides, our status, which we're using to check our statuses in our tests, our PyTest, which we can actually delete this as well now since PyTest is going to be using inside our utils. So let's go over here and say import PyTest. And that is to make sure our fixture runs correctly. And then we also want to make sure that we import everything from our utils. So we can say from.utils import star. And this means import literally everything from our utils.py file so we can use it. So right here, when we type in test to do, this will call our test to do fixture inside our utils. All right, so now if we go ahead and run our tests, all right, so when we run our tests, we can see that, hey, something did break. So let's go ahead and investigate why this is breaking. And that's breaking now because inside our utils, we also need to import our models. So what we can do here is just grab this and come inside our utils and import our models to-dos because it cannot find to-dos in our fixture as we're creating a to-dos because we never imported it over. So now let's go ahead and say PyTest again, and boom, we can see all of our tests are in fact passing, and we're reusing a lot of this stuff. So right here, we have our database connection and all that in the utils file. So now when we create future tests, we can just use the utils just like our test to-dos are to just add so much reusability to our application and to our testing. All right, well, this is what I wanted to show you in this video is how to create this utils.py file so we can add significant reusability within our tests. All right, I will see you in the next video. All right, so far we have created our test2dos.py file, and then we created our utils.py inside our test directory, which kind of has a lot of reusable code that we can use within our future tests. But now let's go ahead and create our admin. So we'll go admin, users, and then authentication. So if we look at our routes and we look at our admin.py file, we can see that our admin.py file is really just going to be able to have our database as a dependency, our user as a dependency, and then we can get certain information from our database depending on if the user is an admin or not. Now, if we go ahead and look at our utils and we go ahead and check out our override get current user, we can see that the user is an admin. So it should work. We'll write all the tests for it to work, and then we'll change around the user's properties to see if they still have access or not. But that should all work once we validate that the user is an admin. So the very first thing we can do is go inside our test directory, say new file, and we will name this test_admin.py. Now, there's a few things that we need to import. So, of course, the very first thing we need to do is import our utils file. Once we import our utils file, we'll get all of these imports, and we'll be able to kind of mix and match some of the functionality so we don't have to rewrite a lot of code. So let's start by saying from.utils import star, and then let's go ahead and say from.routers.admin import getDB and getCurrentDB. And now the reason we are importing these from admin is because each one of our files has our own getDB, which creates a DB session and gets our own current user dependency injection. And we want to make sure that when we override our getDB and our getCurrentUser, we want to override the getDB and getCurrentUser from our admin. So if we look at our routers and we look at our admin.py, and we scroll to the top, we can see that we have our getDB and we override our user dependency with the current user that we're passing in. So we always want to make sure that we are importing our dependency injection, our requirements from the file that we're testing against. All right, so now from here, let's go ahead and say app.dependency overrides getDB equals override getDB. And our app.dependency overrides of getCurrentUser equals override getCurrentUser. All right, and now let's go ahead and write our first test. So here we can say def test admin read all authenticated. Where we want to pass in our test to do, which is our fixture from our utils, which will add a to do before the test is ran and then deletes all the to dos after. We then want to say response equals client.get/admin/to-do, which is going to hit that very first API endpoint within our admin.py file. We then want to say assert response.status code equals status.http 200 OK. And to be able to do this, we need to say from FastAPI import status. And then we want to go ahead and say assert response.json is equal to an array, which is going to be a single element inside. So we can just say one pair of curly brackets where complete is equal to false. Title is equal to learn to code. Description is need to learn every day with an ID of 1. Property of 5. And an owner ID of 1. All right, so now let's go ahead and open up our terminal and let's go ahead and type pytest -- disable - warnings. And just like that, we can see that we're testing against our admin, and this was a successful test. Now, this is testing against our admin to-dos. So if we came into our utils.py file and we changed our admin to like non-admin, and then we reran the application, it's going to fail. And that's because our to-do user is not a admin. So it's going to return a 401 instead of a 200 because we're not authorized. So make sure that your utils.py file, our override get current user, is an admin because we're testing against making sure that this user is an admin. And once it's an admin, you'll see that our admin.py file is running all the tests and they're running successfully. All right, well, I will see you in the next video. All right, so in the last video, we went ahead and added our test admin read all authenticated. And in this video, we are going to go ahead and add our test admin delete to-dos. But before we can just go ahead and start deleting to-dos from our admin, we need to go ahead and import our to-dos. So we can say from ... models import to-dos. All right, so now that that's added, we can scroll down here and we can go ahead and create a new test. So let's go ahead and say def test admin delete to do. Where we're going to pass in our test to do fixture. Response equals client.delete /admin/to-do/1, where we can assert our response that status code is equal to 204. Our DB equals testing session local. With our model that's equal to db.query to-dos. .filter to-dos.id is equal to 1.first, and that's because that's our fixture that we're passing in. And then we can just make sure that our model is equal to none, because once we delete the to-do, we shouldn't be able to query for it anymore. So we're just going to check to make sure that it's equal to none. All right, so now if we go ahead and go back into our terminal and we say pytest without any warnings, we can see that our admin ran successfully, and now we have both checked. So we are able to validate that our delete to do after adding a fixture is successfully deleting the to do. Now let's go ahead and just do one more, and that's just to make sure that what happens if we try and delete a to do and the to do does not exist. So we can go ahead and say def test admin delete to do not found. Where the response is equal to client.delete, where we can just pass in admin/to-do just like before, but this time we'll check for the ID of 9,999, which we know does not exist. We can then say assert response.status code, which is equal to a 404, because when we cannot find a to-do, we return a 404 not found status code, with an assert response.json that is equal to a dictionary with the key equal to detail and the value is equal to do not found. So now if we go back into our terminal and we redo our PyTest, we can see that that passes as well. So our admin passes as well with our to do not found. If we go back into our project and we look at our admin.py file, we can see there's the get to do and then there's the delete to do. So these are the only two pieces of functionality that we have in our admin.py file, and we're successfully testing against them. So in the next video, we will go ahead and continue diving into our application to write more tests to make sure that this application is secure, and I will see you there. All right, so in the last video, we went ahead and created our test admin.py file. And now in this video, we are going to go ahead and write our unit tests for our users. Now, if we look at our users real quick, we can see that there are some dependencies on our database and our user. We have a dependency on our bcrypt when we hash our password. We have a user verification base model where we can get the user that is signed in and we can change the password and phone number. So let's go ahead and do what we usually start with, which is creating a new file, which is test_users.py. All right, so let's go ahead and test our return user. So let's start by saying from utils, import star, from routers.users, import our getDB and our getCurrentUser. And then from FastAPI, let's go ahead and import our status. All right, and now let's go ahead and say app.dependency overrides, where we pass in getDB equals override getDB. And then app.dependency overrides getCurrentUser equals override getCurrentUser. All right, and now let's go ahead and create our first test to be able to test our return user. So let's go ahead and say def test return user, where our response is going to equal client.get/user. And then assert response.status code equals status.http 200 OK. And just with this, let's go ahead and try and do a Py test. Well, immediately we can see that all of our tests pass. So our new tests of user is in fact passing based on this get test. Now, one thing that it is passing is because we are using our override getCurrentUser. Well, if we remember, if we go inside our users.py file, we can see that right here with our get user, we verify our dependencies. If the user is none, we return an exception. And because we're overriding the dependency, it is not returning none because we have it mocked. But then the next step is to return that user based on a database query. Now, we are not saving that override current user. So if we go ahead and look at our utils.py file, we can see right here that our override get current user just returns a dictionary of a mock user. It's not a user that's inside the database. So if we went ahead and just did assert response.json is equal to none, and we went ahead and ran our test again, we can see that it passes. And that's because we are in fact getting the correct status because we're right here. The user is not none, so we return a 200, but there is no user because we're not validating it inside our database. So what we need to do is the exact same thing we did for our test to do, which creates a to do before the test, saves it to the database, so then we can test against it and then deletes all the information at the end of the test. we need to create a fixture for a user, kind of following the exact same thing that this to-do is using, but for a user. So to do this, let's scroll all the way to the top. And right here within our models, let's also add users. And then I also want to say from our auth, import our bcrypt context so we can successfully crypt, is our password getting hashed? That'll be something that we can do. So let's go ahead and say from .routers.auth, import bcrypt context. Perfect. Okay. Now we can scroll down and create our fixture for our user. So right under here, I'm going to make a couple of lines just so we have some more room and space. All right. But here we can go ahead and say app pytest dot fixture def test user, where our user is equal to a new users. And then our username is going to be coding with Roby. Email is going to be codingwithrobytest@email.com. First name Eric, last name Roby. Hashed password equals our bcrypt context.hash, where we're just going to hash a test password. Role is admin. And phone number is 111-111-1111. And then just like we were doing for our to-dos, we want to say db equals our testing session local. We want to say db.add our user, db.commit. And then yield user with engine.connect as connection. Connection.execute a new piece of text, delete from users connection.commit. So what this is doing is after we save a user, run the test, we're just going to delete all the users from the database. So we just have a clean slate for our next test. Perfect. All right, and then once you add this, let's go back to our test users. And now inside here, we want to make sure that we pass in our test user to call that fixture to be able to save a user to the database before we run this application. So let's go ahead and just say test user. And now if we go ahead and say pytest, we should fail. And that's because we now have a user that it is checking against. So we are saying, hey, when we sign in, we're going to try and fetch the user at the ID of 1. And there is a user now, so we can't compare it to is none. Now, one thing that is unique though is the user is going to have a hashed password. And we can verify passwords, but we can't get the exact same string from a hashed password. So what we're going to have to do here is just make sure that each property that's not the password matches what it should. So right here, we can just say brackets of the username is equal to coding with Roby test. And for example, if we went ahead and just ran this application here, we can see that it failed. Did we say coding with Roby? Oops. Let's make this user coding with Roby test. So now if we go ahead and save it, we can see that our application passed. And we're really going to have to do this for like 5 more properties. So I'm just going to copy this 5 more times. And the first one we're going to test against is email, where it's coding with Roby test at email.com. The next one is first name. where it is going to be Eric. Next one is going to be last name, which is going to be Roby. And then it's going to be role of admin. And then phone number of 111-111-111-111. All right, so now if we go ahead and just run our application, boom, we can see that we successfully tested against our /user within our user's API endpoints. All right, well, this wraps up what we wanted to cover in this video, and I'll see you in the next video where we wrap up our test users unit tests. All right, so now that we have our test wrote for us to be able to get the current user, let's go ahead and write 3 more tests for changing the password when it's successful, invalid change password test, and then our test change phone number when it's success. So let's go ahead and just make a couple lines to start with. And I'm going to start by saying def test change password success. And we're going to pass in our test user fixture. And then we can say response equals client.put /user/password, which is going to be our API endpoint, where we need to pass in a JSON object. So we can say JSON equals curly brackets, where password is test password. So we know that it is test password. And then our new password is going to be a new password. And then let's go ahead and just make sure that we assert our response.status code that is equal to status.http 204 no content. All right, so let's go ahead and just run our PyTest. And we can see that that was successful. So we can technically change our password of our test user that we're saving in our database. And one thing to really point out here, so our test user is going to be what we're adding into our database. So we know that this doesn't currently have an ID, but when it gets saved, it will have an ID of 1 because it's going to be the only item saved in our database. And then when we are doing our mock object, that is going to have an ID of 1. So even though we are mocking the dependency, when we actually search and query for the database, it will be using the ID of 1, which is going to be the user that's saved in the database. All right, so for the next test, let's go ahead and check to make sure that we are correctly responding with a 401 unauthorized when an invalid password comes in. So here we can say def test change password invalid current password, where we pass in our test user. And here I'm just going to copy and paste our exact response from above, where we call our /user/password with our JSON object. And then I want to say assert response.status code. But this time we want to make sure that the status is equal to an HTTP 401 unauthorized. And that the JSON response that we get is error on password change. So we can say assert response.json equals a key value pair of detail error on password change. So if we go ahead and run this test, we can see that this just failed, and that's because we just got a invalid password, which is a 204, which equals a 401. And that's because we are, in fact, passing in the same thing. What we actually want to do is say the password is a wrong password. So if we come up here and we just say, hey, this is actually a wrong password, we'll now get the 401 authorized with the right response because it actually ended up being successful. So since it was successful, we didn't get these errors. And this is coming from our users.py, where if the password change is incorrect, we are throwing a raise HTTP exception with a 401 error on password change. So if this verify from our bcrypt context does not validate our password, that's why we're throwing an error here. All right, and now the very last one we want to test against here is a successful phone number change. So we can say def test change phone number success, where we pass in our test user, where response is equal to our client.put/user/phone number / an arbitrary unique number, where we can then say assert response.statuscode equals status.http 204 no content, and that means it's going to be successful. So if the user does exist, which it will because of the IDs that are going to match, we're just going to change the password and get the 204 response. All right, and let's go ahead and run this test. And boom, we can see that we successfully are testing against the phone number change, invalid current password, and successful passwords, and against our return users. So we are testing everything correctly here, and I'll see you in the next video where we keep diving into this application and writing unit tests for pretty much everything. And I will see you there. All right, so now in this video, we are going to create our tests for our auth.py. So if we open up our auth.py and we kind of review what's going on, we can see that we have our JWTs, our API router, our secret key, our algorithms, and then we have our create user requests, our tokens, a get DB. We can see that we only have one DB dependency, so we only need to overwrite one DB dependency. And then we have authenticate user and then create access token, get current user, and some other functionality. So we'll start by creating a test for our authenticate user, which takes in a username of type string, a password of type string, our DB, and then we can verify if the user is in fact a user or not based on our bcrypt context. So we're able to verify the password of the user to see if the bcrypt matches what's currently in the database. So to do this, let's go ahead and just close out of that real quick. And inside our tests, let's go ahead and create a new file. And here we're going to name this test_auth.py. All right, and now the very first thing we need to do is import everything from our utils. So remember, our utils has all of our static users, our fake database, all of that going on. We want to make sure that we move everything over from our utils into our test_auth.py. And we can do that by saying from.utils import star. And now from our auth.py file, we want to import our getDB and our authenticate user. Perfect. All right, and now inside here, let's go ahead and just override our dependency. So we can say app.dependency overrides. Pass in our getDB, which is going to equal our override getDB from our utils. Perfect. All right, now we can go ahead and create our first test for our authenticate user. So let's go ahead and say def test _authenticate _user. And we're going to pass in our test user, which is a fixture from our utils.py. And then we want to say db equals testing session local. All right, so now the very first thing we are going to test is to test with the correct username and password. So we already know it's going to be coding with Roby with test1234 exclamation mark. So we can go ahead and say authenticated user equals authenticate user. We're going to pass in our test user.username. And then we're going to say test password, which is going to be the password. So it's not test123 exclamation mark, it's test password. And we're going to be passing in our DB, which is now pointed to our testing session local. We then want to say assert authenticated user is not none. And then assert authenticated user.username equals test user.username. Let's go ahead and just type in PyTest. And we can scroll up and see that our auth is in fact passing our tests. And remember, we can go ahead to ignore these warnings. We can just go ahead and say PyTest -- disable warnings. And now we'll be able to see all of our tests pass with no warnings. Again, those warnings are because of like FastAPI and some of the libraries and frameworks, not necessarily our code. So it's safe to ignore those warnings. All right, while we're here, let's go ahead and just write 2 more tests within our test authenticate user, which is now going to be for an incorrect username. So we can say non-existent user equals authenticate user wrong username. And we'll pass in our test password DB. And we'll make sure that we assert our non-exist user is false. We can go ahead and write a test for that and run it. And we can see that we get a failure. And that's because user's object is not callable. So we can see that I passed in authenticated user right here. While this is authenticated user, we actually want to call the authenticate user function. So we can remove that. And now when we go ahead and run our PyTest with our warnings disabled, we can see that our auth is now passing with 24 pass, which is going to be the same because we're testing the function, but we can see that all the asserts are passing. All right, now let's do one more for wrong password. So we can say wrong password user is equal to authenticate user test user.username. We'll pass in a wrong password with DB. And then we'll assert the wrong password user is false. All right, and now let's go ahead and just run our tests one more time, and we can see all of the tests in auth have passed. So this has successfully passed our test authenticate user. All right, well, that covers the very first test and setting up our test auth.py file. And I will see you in the next video where we just keep diving into how to test authentication. All right, so in the last video, we went ahead and created this test auth.py file. And in this video, we are going to continue working in this and just create our next test, which is our test create access token. So if we go ahead and open up our routers and take another look at auth, we can see that we need to test for our create access token, which takes in a username, a user ID, a role, and an expires delta, where we encode the sub, which is the username, user ID, and role. We then find an expiration date, and then we encode it and then return a JWT that's encoded with all of the information inside. And here we can see that it's going to need our time delta, a secret, our algorithm, and access to our create access token. So let's go back into our test auth.py, and let's go ahead and add in our create access token, our secret key, and our algorithm. Let's then go ahead and just import our JWT. So we can say from JOSE import JWT. And then we also want to import our date time from time delta. So we can say from date time import time delta. Perfect. All right, now let's go ahead and create the test. So right here, let's go ahead and say we want to create our access token. So we can say def test create access token. where our username is going to equal our test user. Our user ID is going to equal 1. Our role is going to equal user. And then we're going to say expires delta is equal to time delta days equals 1. Well, now we want to create the token. So we can go ahead and say token equals create access token, where we pass in our username, user ID, role, and expires delta. We now want to decode the token without verifying to check its contents. So we can say decoded token equals JWT dot decode token secret key algorithms which is going to equal our algorithm, and our options, which is equals verify signature, which is false. And now we can say assert decoded token of sub is equal to our username. The same thing, our assert decoded token ID equals user ID. And assert decoded token of role is equal to role. All right, so our last test was 24. If we go ahead and run this test, we can see that they all pass again, and we now have 25 passes. So our test of create access token was successful. So we are successfully testing it against creating an access token and making sure that once we decode a JWT, that it all works correctly. So this is how you are able to test your create access token. And I will see you in the next video where we keep diving into our authentication tests for our FastAPI app. All right, so in this video, we are going to go ahead and test our get current user for valid tokens. So if we go into our auth, you can see that we have this get current user right here. It's an asynchronous function, and we'll kind of go over what that means. We've been only using asynchronous functions for our tests when they are an API endpoint, but you can also have asynchronous functions inside the code itself, which is not an API endpoint. And you can see that because we don't have a URL above that a user can call. We only use this as a dependency injection with some of our applications. So we're going to have to do something a little bit different to be able to test this successfully because it is async, but we'll get there in a second. What we need to do though is be able to encode our payload, be able to test our username, ID, and role, and then make sure that a successful user is returned. And then also perhaps test what happens if there is no successful user. So let's go back inside here and let's go ahead and write some code. The first thing I'm going to say is async def test get current user valid tokens. And we need to use async here because we are testing an asynchronous function. And before I proceed, I actually need to scroll up to the top, and inside our auth, let's go ahead and just pass in get current user. All right. All right, so the very first thing we need to do here is say encode equals brackets, where we're going to be creating a object of sub, which is a test user, ID of 1, and role is admin. We now want to create a token, so we can say token equals JWT encode, where we can pass in our encode, our secret key, and our algorithm, which is equal to algorithm. And here we need to say user equals, and we need to say await get current user. So because get current user is asynchronous, we need to say await. And here we can pass in our token that's equal to token. And now we want to make sure that the user is successful. So we can say assert user equals, and then we can create a new object of username is of test user. ID is 1 and user role is admin. All right, so this looks good, but watch what happens when we go ahead and run our PyTest. We can see that we now have one skipped test. So before we had 25 passed, and now we have one skipped test. And we have a skipped test, and that's because PyTest by default cannot test asynchronous functionality. And that's because it can only test synchronous functionality, unless we're doing more like integration testing, which we were doing in some of our other files where we are calling our asynchronous functions by our API endpoint. But when you call them directly using await, PyTest wants you to use an asynchronous library. Now, luckily, PyTest kind of has like a child library that allows you to be able to do this. And this is called PyTest Asyncio. This allows you to be able to test asynchronous functionality within your code base. And to be able to get it in your application, we need to say pip install PyTest-asyncio. All right, so once we installed it, we can see that I successfully installed PyTest Asyncio. Your version might be slightly different, but all in all, we have it installed. We now need to scroll up to the top and say we want to say import PyTest. And now we can successfully be able to call our Asyncio library by labeling this function as a PyTest Asyncio. And we can do this by adding a decorator at the top by saying @PyTest dot mark. So we're going to mark this function as Asyncio. So once we import PyTest Asyncio and we mark this function as a async application, and now if we run our application here by saying PyTest disable warnings, we can see that we can successfully now test our asynchronous functionality. So instead of getting skipped, we have 26 passing. All right, so in the next video, we're going to do the opposite, where we're going to be testing if a user is not valid, and I will see you there. All right, so in the last video, we were able to successfully test if our get current user has a valid token. And now in this video, we are going to do the exact opposite. We are going to test to see if it has some kind of missing value, like a missing payload. So let me scroll this down. And the very first thing we need to do is just import our HTTP exception from FastAPI. So let's go ahead and say from FastAPI import HTTP exception. All right, now scroll back down and let's go under here and let's create a new test, which again is going to need our PyTest mark asyncio to be able to successfully implement the application and test. So what we can do here is just say @pytest.mark.asyncio. And then underneath we can say async def test get current user missing payload. And now we need to generate a token with a missing sub and ID for testing. So we can say encode equals role of user. Where we can say token equals JWT.encode. Where we can pass in encode secret key and algorithm that's equal to algorithm. And then we can say with PyTest.raises HTTP exception as exc info. So we're just going to say hey, if an HTTP exception is called, let's go ahead and await our get current user token equals token. And then after this, we can say assert our excinfo.value.status code is equal to 401. And then we can say assert excinfo.value.detail equals could not validate user. All right. And really what we're saying here is if while we're testing an exception raises, which does happen, so inside our get current user, if everything fails, we throw an exception. We're just going to say, hey, if an exception happens, let's call it this. So we run this application. We know it's going to fail here because we corrupted the encode. We're going to get this information and we can check to make sure it's 401 in that we cannot validate the user. So here, if we just go ahead and say PyTest, no warnings, we should get 27 passes. So boom, there's 27 passes now. So we have successfully tested our FastAPI application. Hope you liked this area on unit testing and integration testing, and I will see you in the next video.